Okay, 1-6b. Let's finish it up. Let's finish up our chapter. All right, we're still doing graphs, but today we're going to do some of the distortions on graphs. So we're going to talk mostly about stretches and shrinks. Stretches and shrinks. Okay. All right, we're going to have two of them. One's easier than the other. Vertical stretches are pretty easy, but horizontal stretches and shrinks are really tricky because the horizontal stretch is happening on the x, and the x is inside of the function. Okay, the one on the outside is just affecting all the y values. So let's do horizontal first. So a horizontal distortion looks like this. Y equals f of x over c. Okay? And if c is greater than 1, what happens is we get a stretch in our graph. Stretches it out horizontally, stretches it this way. And if c is less than 1, then we will get a shrink. C is less than 1, you get a shrink. Okay? Those are going to be tricky. You're actually going to have to plug in x over c into your function to change the stretch or shrink. Now, a vertical stretch or shrink, vertical affects the y values, okay? So if we were going to stretch it vertically, which we did in our homework, like when we had a 2 in front of the absolute value, we stretched it 2. We went up 2 and over 1. So what these look like is you take that constant and then you just multiply all of your y values by it. It's nice and easy. It's just a constant times f of x. And the same thing, c is greater than 1, you get a stretch, c is less than 1, you get a shrink. I never ask you, is it a stretch or a shrink, okay? But they'll tell you, stretch it by, they won't ever ask you which one's which. All right, so let me show you an example of each so that you know what we're doing. Number 1. Okay, suppose that we have y1 is going to be the function x cubed minus 16x. X cubed minus 16x. So this is not a parent function. It's really not one that we shift or anything. This is just a function. And we're going to take this function and we are going to stretch it vertically by a factor of 3. So let me write that down. Letter A, by the way. Stretch vertically by a factor of 3. All right, so when you have a vertical stretch, it's pretty simple. You're going to take that constant and multiply it times your function, okay? So we'll call it y2. So y2 would equal, so take 3 and multiply it by the entire function, x cubed minus 16x. And then go ahead and clean it up, okay? And we write that y2 is equal to 3x cubed minus 48x. Okay? All right, and then if you were to graph this on your graphing calculator, it's over there, basically what happens, I'll just show you what happens, okay? So let's say that you have the graph and it looks something like this. This is the original y1. The stretch on y2 will be that it stretches it like that. It stretches it all out, okay? That's pretty much what it looks like. It still goes through 0, 0, though, like that. It affects all the y values, get all stretched out. Okay, so now let's do part B. Then let's go ahead and do a horizontal shrink by 1/2. Same function, though, same y1. We'll do a horizontal shrink by 1/2. Now remember, horizontal are our x values. And so this is going to shrink all of our x values by 1/2. So this is what you want to do. You want to do f of x over 1/2. And you're probably like, ew, that's gross. Well, let's fix that, okay? This is really what? F of, anybody? 2x, thank you. F of 2x. Okay? Remember, you take the 1/2 on the bottom and you flip it. Dividing by 1/2 is the same thing as multiplying by 2. How many halves are in 30? 60. There you go. Okay, so take f of 2x now. So our original f of x, or y1, whatever you want to call it, was x cubed minus 16x, right? Now let's go ahead and do f of 2x into here. This is going to shrink it horizontally by 1/2. It feels weird, huh? That you're multiplying everything by 2, but you're shrinking it horizontally. So plug in 2x cubed minus 16 times 2x. And so you get 8x cubed minus 32x. And that would be your answer there. Okay? And then if we graph that, you'll see that all of the x's have been stretched out onto the, like that way. It's pretty cool. All right, so you get the difference between them. So when you're vertically stretching something, you multiply the entire function by it. But when you're horizontally stretching or shrinking, you're going to plug it into the function. So let's do another one of those. Number 2. All right, suppose that you have f of x equals, let's do x squared plus 4. Okay? And so let's do 2 of them. Let's do a vertical shrink of 1/4, and then we'll do a horizontal stretch this time. All right, so a vertical shrink. This is the easy way. Vertical is easy. It happens to all the y values. So our new function, I'm just going to call it y2, will equal 1/4 times all of f of x squared plus 4. So y2 will equal 1/4 x squared plus 1. Everything gets shrunk. Okay? This is the graph of x squared plus 4. You know how to graph that, I hope. 1, 2, 3, 4. Okay? Up like that. And then when I vertically shrink this to 1/4, everything gets shrunk down, and you're at 1 now, and it's 1/4, and so it actually goes like super wide like that. All gets shrunk down. Kind of weird. Okay, and then the second one, let's do a horizontal stretch by 3. Horizontal stretch by 3. Okay? So don't forget, horizontal goes on the inside of the function. We are now going to do f of x divided by 3. Now, if it's a fraction, you want to take it and move it up, but this is just a whole number. So x over 3, and then we're going to plug that in. So we have x over 3 squared plus 4. And then go ahead and fix that up. So you get x squared over 9. So I would probably write this as 1/9 x squared plus 4. Okay? So it gets horizontal stretched by 3. There you go. Now, I'm not going to make you graph those a lot of times. They just ask you to find them. Find what would the graph be if it was shrunk by whatever and stuff like that. All right, couple more. 2 more problems. Number 3. All right, so now we're going to put all the transformations together. Okay? So let's suppose that you have your parent function, f of x equals x cubed. Okay? And we're going to take x cubed and we're going to do a transformation in this order. So order matters here, in this order. You're going to horizontally shift 2 to the right. We're going to go 2 to the right. Okay. We're going to do a vertical stretch of 3. And then we're going to translate 8 up. Okay, now they're not going to ask you to graph it. They're just going to ask you to tell me what the function would look like if these things happened in this order. 1, 2, 3. Okay? All right, so let's do it. Here we go. So here's our new function. You can call it f of x if you want to. F of x equals. So if I have a x cubed function, the cubic function, and I'm shifting 2 to the right, then the first thing I would do is I would go, what? X minus 2. Very good. X minus 2 on the inside. Okay? So that's the first thing. The second one is this function is now vertically stretched by 3. So what am I going to do? Put a 3 out front. Multiply the thing by 3. And then I'm going to shift it up 8. So now then it's plus 8. And that's it. That's all they want you to do. Pretty good, huh? Okay, let's do this in the opposite order. Opposite order is going to affect something. It's going to make one little change. Most of it's going to stay the same, but it affects one thing. So now the opposite order says that I'm taking my cubic function and I'm going to shift it up 8. I go 8 first. Okay? And now I'm going to apply a vertical stretch on this. So then I'm going to have to multiply the whole thing by 3. Okay, so the next one would be then multiply this entire thing by 3. So I get 3x cubed plus 24. Okay, it affected that 8 that I already shifted up. It affected that part. And then finally, I'm going to go to the right 2. So the right affects the x. So I'd go x minus 2 cubed plus 24. So it makes a difference in what order you do things. Okay, I wouldn't, if I was going to do, and I was going to graph this right here, this one, I wouldn't want to shift up and to the right and then distort it, because the 3 is only being distorted on just the cubic part, not the 8 part. All right, one last one for you. Number 4. Kind of skipped this one in first period on accident, so whoopsies if you're listening, sorry. Okay, so here we go. I'm going to draw a graph, some weird graph. That we don't know what it is. We don't have a parent function for this. So go ahead and graph this. We'll go with -1, -2, and put a dot there. And then at 0, 2, we'll put a dot there. And then 1 over at 4, 0. 1, 2, 3, 4, 0. And then let's say that our graph looks like this. It's kind of like a semicircle round here and then a straight line there. Okay? So there you go. That's the shape of our graph. That is our original, this is our y equals f of x graph. All right, now what we're going to do is we're going to take this thing and we are going to graph y equals 2 times f of x plus 1 minus 3. Woo! We're going to see what all of that does to it. Okay? There's 2 things you really don't need to worry about order here. You can do the 2 times this first and then shift it, or you can shift it left and right and then do the 2 times. It really doesn't matter. So let's just do the 2 times this thing first. So if I'm going to take this and I'm going to do 2 times the f of x, 2 times all the y values, that means all of my y's are going to be twice as much on that x. So this one right here, what's y? Y is 0, right? Yeah, x is -2, so y is 0. 2 times 0 doesn't affect it, okay? But my y right here, which is that 2, that's going to be affected. So now my y at this point is what? 4. Okay, so this blue point is here, this one's there, and then this one, which is at 0, doesn't get affected either. All of my f of x's, all of my y values are being multiplied by 2. If I multiply 0 by 2, it's still 0. It's like, oh, you have twice as much money as I do? Okay, well, I have $0, so you do too. Okay. All right, so then this is going to be a curve to here. That's a curve. And then a straight line. So do you see all we've done is we have stretched this function by 2, stretched it out. All right, now take that, and the rest of it's pretty easy. That's the hard part, is the times 2. It's like, whoa, what did we just do? We multiplied all of our f of x's by 2. And now we're going to shift 1 to the left and 3 down. So take these 3 major points on your graph, and I'm going to shift them 1 to the left and 1, 2, 3 down. So I'm right here. And this one, 1 to the left, that's this way, and 3 down. 1, 2, 3. So now I'm here. And this one too, 1 to the left, 1, 2, 3 down. And so my graph is rounded here and straight there. Okay? And that's what this one is right here. The whole thing is in green. It's tough. And they'll say do something like y equals negative f of x. So you have to take that original shape that's in black, and what would you do to it if they said negative f of x? You'd flip it over that, you just flip it all upside down. So it would go like to 2 like that, and then to there, so that it's a reflection, okay? Or if it was f of negative x, you would flip it over the y-axis. So they make you do a bunch of things just so you know that, hey, not everything is an x squared or a cubic or whatever. You can have some weird shapes. Let's go ahead and shift them, reflect them.